especially the standard deviation, which is fantastic. I love that. I love that. But I want to make sure we're all on the same page. So first of all, here's the distribution I see that all of you have as I walk around. These are the three. This is I die, which means I make 9640, or whoever my beneficiary is makes 9640. That happens that often. So 269 times out of 100,000. That's me getting disabled, unable to work, but not dead, which happens a freakishly large period of time. 12% is freakishly large, yes. And lastly, if I don't die nor become disabled, I'm going to lose 360 bucks. Now I lose 360 on all three of these, right? Just like I lost $1 on all four of these. It's just that the dollar gets repaid in all except for one outcome. So you see the parallel between the gamble and the life insurance? It's a gamble. It's not called an ante, it's called a premium, but it's exactly the same thing. You pay in to play the game. And the game is, roll the die, are you going to live or not? I mean, I don't want to make it sound comical. It's not comical, but that it is a gamble. The actuaries know this, and they set the rates accordingly. Nick, go ahead.
That 0.87731, how did you get that?
Yeah.
This and this together is 12.269%. Whatever's left has to be the last one to get to 100%.
But you have to do 1 minus those instead of 100.
Oh, yes, and that brings up a good point. Careful with percentage versus decimal. If you do 100 minus these two, you're going to get an inflated value of like 99 and some change.
We would have to move the decimal over.
Yeah, don't. Just leave it as a decimal.
Okay.
Do 1 minus that. Thank you. Thank you for verbalizing that. That's one of those things we often forget, especially those of us coming out of Math 111, because you never talk about percentages then. Well, sometimes you did, like exponential decay and stuff, but it's one of those things you just forget how to, like, my pants are 50% off. Like, how much is it? Logarithm. It's cut in half. It's American math students. You guys are tortured by stuff you don't need for in a lot of cases. Cool? All right. Now, real quick, I'm gonna draw. Now, I didn't ask you to do this, I don't think, but I'm gonna draw a histogram of this.
Yeah, the little circle thing on the line, that's 823.
Okay. So, now, I mean, let me change it too. Hang on. I gotta change the scale. Yeah, it's a little ridiculous. Oh, shit, doesn't like that. Too many breakups. Yeah. Okay. So there's the histogram of the data. Perfectly useless. There's your negative 360. There's your positive 1640. And somewhere over here, don't know where. Let's see if I can find it. Watch it. Is that it? No. Yeah, there it is. There it is. There is your 0.00269. So small, it's not actually peaking up. Now, this is why I didn't bother having you do a histogram. Don't, if you're trying, don't worry about it. It doesn't really tell you anything. I mean, it's basically showing you 3 bars, which correspond to the probabilities in that distribution. What I find interesting is if you change the graph to a modified box plot, this is where it gets even more fun. That's the box plot. Everything's an outlier except for not dying. And look at not dying. It's all, the boxes and the whiskers are all together. The only other 2 data points, the 1640 and the other, they're outliers. Now, why is this? Nick, you asked the question at the beginning of class, why do you do Q3 minus Q1? My answer to you, because that's what gets done. I don't have a good answer other than that. But the problem is, if I don't die 87% of the time, that means you've got Q1, Q2, and Q3 all wrapped up in that. Think about it, 87%, yeah? That's bigger than 75%. It's also bigger than 50%. It's also bigger than 25%. So all the quartiles are me not dying and therefore losing 360 bucks. Now, if you don't believe me, that's totally fine. Run one of our stats, which I'm sure you all did, yes? Yep. So you ran one of our stats, L1, definitely L1, L2. You got to get those weights in there. And this is the screen you needed.
Yeah.
On average, you're going to lose 93 bucks. Let's come back to that. This, now I think you understand why it's so big. That box plot is all over the place. The standard deviation has to be obnoxious. It's got to do the average distance of all those crazy 10,000 and 2,000 and 0. Here's what I was talking about. 25th percentile, 50th percentile, 75th percentile. They're all negative 360. That's why your box plot crunched down to one line. because the data set doesn't have that many outcomes, and one outcome overshadows the rest. Thankfully, that outcome is not dying, right? Thankfully, the outcome is not dying nor becoming disabled. If you think about it, the outcome of not dying is actually much higher. It's 99.8%. But not dying nor becoming disabled overweights everything else in the distribution. So now here comes the question, and I didn't ask you this one for points, but at number 6, what does that expectation mean? So negative 93.1, that's the average, yes? Ignore the standard deviation for now. That's not really that important. What does the expectation mean?
You're gonna lose that much money.
When are we going to lose $93?
On average.
That's what I need to hear.
Over time.
Yes! And from an actuary's point of view, that means that every single person that buys this policy essentially is giving them 93 bucks. That's what the actuaries know. A negative 93 for the policyholder is a positive 93 for them. It has to be, doesn't it? They're running a business. They have to bring money in for one reason. Why do they need money?
Because they're a business.
Because they're a business, and they have to pay people out that actually do die. Right? That's the point. Insurance was invented for that reason. To create a pool of cash, and those who needed it can then dip into that pool of cash. It's very socialistic if you think about it. That was the whole reason insurance was invented in the first place. Because life insurance is not needed all the time by everyone. It's needed occasionally by 1 or 2 people. So you create this system. What this allows the actuaries to do, that's a big system, this allows them to get in there and actually analyze the whole system. And they can adjust the premiums. They might be able to figure out that negative 93 is not doing it. We need negative 100 per person. Let's adjust the premium accordingly. That's what your quiz will be next week. For next week, I'll have you play with the premiums or the payouts for this. Alan, go ahead. I thought I saw a hand go up. Maybe I didn't.
Well, I had a
Go ahead.
question earlier, but you already answered it.
Oh, I did? Okay, okay. But that's the idea. This allows the actuaries to look at all of those premiums coming in. All those premiums and getting an average, as Marty said, on average, as somebody else said, over time. Very, very nice. Nick, go ahead.
Does that mean if somebody dies that we are basically paid?
Yes, and when you die, somebody else will pay for you.
Okay.
Yeah, you got it, man. That's exactly right. Kendra.
That $93 a year over time?
Yes, this is an annual policy. So every year, for every person that signs up for this policy, essentially it's just that person handing them 93 bucks. Even the ones that die.
Because eventually you'll get the $10,000.
Exactly.
But you'll have paid more in.
Exactly. That's the whole point, sister. That's the whole point. Make sense? Very, very good synopsis, actually. And Nick's I hope I didn't sound too cavalier when I answered Nick's question. But you're obviously, does that mean we're paying for somebody else's? Yes. And then somebody else will pay for you when it's your turn.
So it's basically like symbiotic.
It is. That's the whole point of the insurance industry originally. Now, it might have become something else. But the whole point was we created a pool of money that we'll tap into. It happened around here. We have sick day accrual around here. It's a state mandate. We have to get, I think, 12 sick days a year. And hardly any of us use them because thankfully, we don't get sick that much. But when somebody gets really sick, we can then donate our sick days to those people who have used more than their 12. So you get 10 or 12 people together to each give 10 days, all of a sudden you've got a year's worth of sick days you can give to somebody. It's kind of the point. It's kind of like a nice community thing, just like this is. Now, business aside, that's the philosophy behind it. Cool?
Yeah.
All right, now keep on going and look at the number 9, I think number 9. The ones below you can skip, the 7 and 8, 9. Or the 7 and 8, I just have you do the graphs again. You can ignore that if you want to. Just go straight to the New York Lottery. This is one of my favorite examples of math students paying attention in class. Yeah. One of my favorites. Take a look at this one. You're crying, Carl. I'm sorry.
I know. You started as funny as you were.
Very emotional.
Oh, awesome. I'll just put this right here with everything else. Dude, good luck. Good on it.
Yeah, the outliers were everything but just outliers.
You are more funny.
I'm sorry. What is it?
Negative 3 to 6.